Continuous delivery, automating the software delivery process. Continuous delivery is a software development practice where code changes are automatically built, tested, and prepared for a release to production. It aims to make software releases more frequent and reliable. Key principles of continuous delivery. First, automation first. Automate build, test, and deployment processes to reduce manual errors and increase reliability. Every change should trigger an automated pipeline. Second, continuous testing. Test early and often throughout the delivery process. Automated tests should run on every change to provide immediate feedback. Third, visibility and feedback. Make the state of the system and the delivery process visible to everyone. Fast feedback loops enable quick problem resolution. Fourth, build quality in. Quality is everyone's responsibility. Detect and address issues early in the development process rather than finding them in production. Continuous delivery pipeline consists of 4 stages. The first stage is commit stage where build, unit tests, and code analysis take place. The second stage is acceptance stage where functional and integration tests happen. The third stage is user acceptance testing stage, where UAT takes place. The fourth stage is production stage, where deployment and monitoring take place. Each stage provides feedback and only promotes quality builds to the next stage. Failures are caught early in the pipeline. Infrastructure as code. Key benefits. Consistent environments across development, testing, and production. Version-controlled infrastructure changes. Automated provisioning and configuration. Self-documenting infrastructure. Reduced configuration drift. Here is an example of Terraform code. We define the AWS provider. Then we create a web server instance. The resource is AWS_instance in web. AMI equals AMI-0C55B159CFAF1F0. Instance type equals T2.micro. Tags. Name equals web server. Deployment strategies. First, blue-green deployment. Maintain 2 identical environments, blue and green. Deploy the new version to the inactive environment, test it, and then switch traffic. Pros are 0 downtime and quick rollback. Cons are resource-intensive and database migrations. Second, Canary deployment. Release new version to a small subset of users first, then gradually increase the percentage as confidence builds. Pros are early feedback and reduced risk. Cons are complex setup and monitoring overhead. Third, feature toggles. Deploy code with new features disabled, then enable them selectively via configuration without redeploying. Pros are decoupled deployment and targeted rollout. Cons are technical debt and testing complexity. Fourth, rolling deployment. Gradually replace instances of the previous version with the new version, one subset at a time. Pros are simple to implement and resource efficient. Cons are version inconsistency and rollback challenges. Popular CI/CD tools. First, Jenkins. Open source automation server with hundreds of plugins to support building, deploying, and automating any project. Features. Highly customizable and extensive plugin ecosystem. Second, GitLab CI/CD. Built-in CI/CD in GitLab that lets you test, build, and deploy your code with automated pipelines. Features. Integrated with GitLab SCM and YAML-based pipeline config. Third, GitHub Actions. Automate workflows directly from your GitHub repository with event-driven actions. Features. Native GitHub integration and community marketplace. Fourth, Circle CI. Cloud-based CI/CD tool that automates the software development process with fast feedback loops. Features. Fast build times and Docker-first architecture. Fifth, Azure DevOps. Microsoft suite of development tools for teams to plan, build, test, and deploy applications. Features. Comprehensive toolset and strong Azure integration. Sixth, AWS Code Pipeline. fully managed continuous delivery service that helps automate release pipelines for fast updates. Features: AWS service integration and serverless architecture. Categories are self-hosted, cloud-based, and platform-specific. Pipeline as code. Key benefits: pipeline as code treats CI/CD pipeline configurations as code, stored in version control alongside application code. Version-controlled pipeline changes. Reusable pipeline templates. Self-documenting processes. Consistent pipeline execution. Here is an example of Jenkins declarative pipeline code. Pipeline. Agent. Docker. Image node :14. Stages. Stage build. Steps. SHNPM install. SHNPM run build. Stage test. Steps. SHNPM test. Key metrics for continuous delivery. First, deployment frequency. How often an organization successfully releases to production. Higher frequency indicates more agile delivery capabilities. Example: daily deployments versus monthly releases. Second, lead time for changes. Time it takes for a commit to reach production. Shorter lead times indicate more efficient delivery processes. Example: hours versus weeks to production. Third, change failure rate. Percentage of deployments causing a failure in production. Lower rates indicate higher quality and more reliable processes. Example: less than 15% of changes cause incidents. Fourth, mean time to recovery. How quickly service can be restored after a failure. Faster recovery times indicate more resilient systems. Example: minutes versus hours to restore service. Continuous delivery best practices. First, trunk-based development. Work in small batches with frequent merges to the main branch. Avoid long-lived feature branches to reduce integration conflicts. Second, test automation. Implement comprehensive automated testing at all levels: unit, integration, and end-to-end. Tests should run on every change. Third, code reviews. Enforce peer code reviews to maintain quality, share knowledge, and catch issues early before they enter the delivery pipeline. Fourth, monitoring and observability. Implement robust monitoring and alerting for both the application and the delivery pipeline to quickly detect and resolve issues. Fifth, security as code. Integrate security scanning and compliance checks directly into the pipeline. Treat security as a continuous process, not a gate. Sixth, documentation. Keep documentation up to date and version controlled alongside code. Document architecture decisions and pipeline configurations. Getting started with continuous delivery. Implementation steps. First, assess your current delivery process and identify bottlenecks. Second, start with automated builds and basic testing. Third, implement version control for all artifacts, code, config, infrastructure. Fourth, create deployment pipelines with quality gates. Fifth, gradually expand automation and monitoring. Recommended resources. Book Continuous Delivery by Jez Humble and David Farley. Book The DevOps Handbook by Gene Kim, Jez Humble, Patrick Du Bois. DORA Research Program. DevOps Research and Assessment Metrics. CD Foundation. Community resources and best practices. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.